In this class, we discussed the binomial option pricing model. The binomial option pricing model is a discrete time option pricing model in which the underlying price, that's for an equity option, the share price, either rises or falls at the end of each time period. The time to expiration of the option is divided into different periods, for example, using days, weeks, or months, with the result that the time and therefore the price of the underlying change gradually over each period in the model. The option valuation model that we discuss in this class is the model of Cox, Ross and Rubinstein. Let's discuss how we can use the one-period binomial model to calculate the option price. The first step is that we have to calculate the factors that result in an up and down move of the underlying share price. The up factor can be calculated as follows. We take the Euler's number to the power of the annualized volatility. The annualized volatility can either be calculated using the historical volatility or using the implied volatility. The annualized volatility is multiplied by the square root of one period in the binomial model. Multiplying the volatility by the square root of one period in the binomial model assumes that the stock returns are not correlated with each other. That means we assume an autocorrelation of the stock returns of 0. To calculate the down factor, we take the Euler's number to the power of minus the annualized volatility times the square root of one period in the binomial model, and that's the same as taking the reciprocal of the up factor calculated above. The second step to apply a one-period binomial model to calculate the option price is to determine the risk-neutral probability of an up move and the down move of the underlying share price. The risk-neutral probability of an up move is calculated as follows. We take the Euler's number to the power of the continuous compounded risk-free rate times one period in the binomial model minus the down factor calculated in step 1 divided by the up factor minus the down factor. Since the sum of the risk-neutral probabilities is 1, we can calculate the risk-neutral probability of a down move with the following equation. So we take 1 minus the risk-neutral probability of an up move. The third and last step in a binomial option pricing model is to calculate the expected option price. The expected call price is calculated as follows. We take the risk-neutral probability of an up move times the call price after an up move of the underlying share price plus the risk-neutral probability of a down move of the underlying share price times the call price after a down move. And that's discounted back over one period in the binomial model using the continuous compounded risk-free rate. Let's apply now the 3 steps discussed in order to calculate the call price. On 16th of November 2022, the Mercedes-Benz Group stock trades at the price per share of 61.15 euros. The annualized implied volatility of the share price is 36%. A call option on the Mercedes-Benz Group stock has a time to expiration of 6 months and a strike price of 60 euros. The continuously compounded 6 months risk-free interest rate approximated by the 6 months Euribor is 2.311%. And now we have to calculate the price of the call option using a one-period binomial model. The first step is to calculate the up and down factors. According to the Cox, Ross and Rubinstein model, we can calculate the up factor as follows. The up factor, that's the Euler's number to the power of the annualized implied volatility, which is 36%, times the square root of one period in the binomial model, which is 6 months for our 6 months call option, times the root of 6 months divided by 12 months. If you're entering the figures in your calculator, you should obtain an up factor of 1.290. The down factor is the reciprocal of the up factor in the Cox-Ross and Rubinstein model. So we take the Euler's number to the power of minus the analyzed volatility of the stock times the root of 6 months divided by 12 months. That's the same as the reciprocal of the up factor, so 1 divided by 1.290. And if you're entering the figures in your calculator, you should get a down factor of 0.775. With these up and down factors, we can calculate the share price after an up move and after a down move. To visualize the calculation, I draw a binomial tree over a period of 6 months. The share price on the valuation date is 61.15 euros. And now we can calculate the share price after an up move. The share price after an up move equals the share price on the valuation date times the up factor. If you are entering the figures in this equation, then the share price on the valuation date is 61.15 euros multiplied by the up factor of 1.290. That gives a share price after an up move of 78.88 euros. The share price after a down move is calculated taking the share price on the valuation date times the down factor. The share price on the valuation date is 61.15 euros multiplied by the down factor calculated above of 0.775. That gives a share price after a down movement of 47.39 euros. The next step to calculate the option price using a one-period binomial model is to calculate the risk-neutral probabilities of an up and down move of the share price. As we have already discussed before, the risk-neutral probability of an up move is calculated using the following equation. We take the Euler's number to the power of the continuous compounded risk-free rate times one period in the binomial model minus the down factor divided by the up factor minus the down factor. And now let's have a look where this equation does come from. To calculate the risk-neutral probability of an up and down move, we assume a risk-neutral world. In a risk-neutral world, the expected return is given by the risk-free rate. Hence, we can calculate the expected share price at the end of one period, taking the share price today, multiplied by the Euler's number to the power of the continuous compounded risk-free rate times one period in the binomial model. That equals the risk-neutral probability of an up move times the share price at the beginning times the up factor. And please note that the share price at the beginning times the up factor, that's the share price after an up move, plus the risk-neutral probability of a down move times the share price at the beginning times the down factor, and the share price at the beginning times the down factor, that's the share price after a down move. Please note that the sum of the risk-neutral probabilities is 1. So we take the risk-neutral probability of an up move plus the risk-neutral probability of a down move, that equals 1. And if you rearrange this equation according to the risk-neutral probability of a down move, then we get 1 minus the risk-neutral probability of an up move. And now we can replace in the equation the risk-neutral probability of a down move by 1 minus the risk-neutral probability of an up move. In doing so, we will get the following equation: the expected share price at the end of the period equals the risk-neutral probability of an up move times the share price after an up move plus 1 minus the risk-neutral probability of an up move times the share price after a down move. And now we can rearrange this equation according to the risk-neutral probability of an up move. The first step is that we divide both sides of the equal signs by the share price at the beginning. In doing so, the share price at the beginning cancels out. We will get then the following equation. We have the Euler's number to the power of the continuous compounded risk-free rate times 1 period in the binomial model equals the risk-neutral probability of an up move times the up factor plus, and now we can multiply out the second term to the right of the equal sign. That's plus the down factor minus the risk-neutral probability of an up move times the down factor. Next, we can multiply out the risk-neutral probability of an up move that we have to the right of the equal sign, and we can deduct at the same time on both sides of the equal signs the down factor. In doing so, we'll get the following equation: the risk-neutral probability of an up move times brackets the up factor minus the down factor equals the Euler's number to the power of the continuous compounded risk-free rate times 1 period in the binomial model minus the down factor. And then we can divide both sides of the equal signs by the difference between the up and the down factor. That gives then the following equation for the risk-neutral probability of an up move. That's the Euler's number to the power of the continuous compounded risk-free rate times 1 period in the binomial model minus the down factor divided by the up factor minus the down factor. That's the equation which is used to calculate the risk-neutral probability of an up move in the Cox-Ross-Rubinstein model. Let's apply now this equation to calculate the risk-neutral probability of an up move in our example. The risk-neutral probability of an up move, that's the Euler's number to the power of the 6 months Euribor, which is 2.311% in our example, times 1 period in the binomial model, which is 6 months divided by 12 months, so 0.5 years. The time expressed in years, so 0.5 years, minus the down factor, which is minus 0.775, divided by the up factor of 1.29 minus the down factor of 0.775. If you're entering the figures in your calculator, you should get a risk-neutral probability of an up move of 0.459. The sum of the risk-neutral probabilities is 1, as we've already discussed before. So the risk-neutral probability of an up move plus the risk-neutral probability of a down move equals 1. Hence, the risk-neutral probability of a down move is 1 minus the risk-neutral probability of an up move. So the risk-neutral probability of a down move is 0.541. The third and last step in the 1 period binomial model is the calculation of the expected call price. To calculate the expected call price, I draw the binomial tree for 1 period. And we know that the share price at the beginning, that is a share price on the valuation date of the Mercedes-Benz Group stock, is 61.15 euros. Then we've already calculated the share price after an up move, which is 78.88 euros. And we've also calculated the share price after a down move, which is 47.39 euros. The call option on the Mercedes-Benz Group stock has a time to expiration of 6 months, and we know that at the expiration date, the call price is given by its intrinsic value and the time value is 0. To calculate the call price after an up movement at the expiration date of the call, we can take the maximum of €0 or the share price of 78.88 euros after an up move minus the exercise price of 60 euros. Therefore, the call price after an up move is 18.88 euros. The call price after a down move at expiration is calculated as follows. We take the maximum of €0 or the share price after a down move, which is 47.39 euros, minus the strike price of 60 euros. Hence, the call price after a down move is 0 and expires worthless. And now we can calculate the expected call price on the valuation date. To calculate the expected call price, we can take the risk-neutral probability of an up move times the call price after an up move plus the risk-neutral probability of a down move times the call price after a down move. And the sum of the probability-weighted call prices after an up and down move are discounted back using the continuous compounded risk-free rate. If we enter the figures in this equation, then we have to begin with the risk-neutral probability of an up move, which is, in our example, 0.459, times the call price after an up move of 18.88 euros, plus the risk-neutral probability of a down move, which is 0.541 in our example, times the call price after a down move of 0. The sum of the probability-weighted call prices after an up and down move are discounted using the continuous compounded risk-free rate over a period of 6 months. If you're entering the figures in your calculator, you should get an expected call price using the one-period binomial model of 8.57 euros. In this example, using a one-period binomial model, the call price has been calculated on the basis of one period of 6 months. A more accurate option value is obtained by increasing the number of periods in the binomial tree. For example, days can be taken for each period instead of a single 6 months period, which results in a more realistic option price.